How are you, my friends? This is lecture 19 of the pre-calculus course, inverse trigonometric functions. Just before I start, I would like to remind you of some information about the inverse functions from lecture 1. For the function to have an inverse, it must be one-to-one function. Also, to find the inverse, we follow the 4 steps in lecture 1. You can go please and check it. The domain of the f is the range of the inverse, and the range of f is the domain of the inverse. Always we can use that. Also, f circle f inverse of x is equal to f of f inverse of x is equal to x. The same thing for f inverse circle f of x is equal to x. We call these cancellation properties. Now let's start with the sine function. We know the graph of the sine function. You can see the graph of the sine function in lecture 15. This function is not one-to-one, so there is no inverse. So what do we do here? We restrict the domain from minus pi over 2 to pi over 2. So if we take only this domain, restricted the condition on the domain from minus pi over 2 to pi over 2, the function sine becomes one-to-one, so it has an inverse. To find the inverse, we interchange x and y, so x will be sine of y. Let's solve for y. So we can write y will be sine inverse of x. This is the way we read it. Y equals sine inverse of x. Now the domain of the inverse here is minus 1-to-1. From where we get that? From the range of the f, because you know the range is minus 1-to-1. The range of the f inverse, see this one, the range will be minus pi over 2 to pi over 2. That's in the inverse. It's coming from the domain, which is the restricted domain. So we write y equals sine inverse of x, or sometimes we write arc sine of x. Arc sine means the angle or the arc whose sine is the x. So x is a number between minus 1 and 1. So this is the sine function, restricted domain from minus pi over 2 to pi over 2. And this is the graph of the inverse, y equals sine inverse of x. If you take any point there, pi over 2, 1, you can interchange x and y, so it becomes 1 pi over 2. And 0, 0 will be 0, 0. Minus pi over 2 minus 1 becomes minus 1 minus pi over 2. So the red one is the graph of the inverse. Remember, the inverse has domain minus 1-to-1 and the range minus pi over 2 to pi over 2, which is defined in quadrant 1 and 4. Now, these are cancellation properties, as I mentioned before. So we can say sine inverse of x is equal to x only if x between minus 1 and 1. That's the domain of the inverse. Now, if we have sine inverse sine of x is equal to x, x must be between closed minus pi over 2 to closed pi over 2. Remember these cancellation properties and the conditions. Let's start with 2 simple examples. Sine inverse of half, sine inverse of 2. Let's find the value of this, find the value of that. The first one is easy. Sine inverse of half, what does it mean? It means find the angle in quadrant 1 or 4 whose sine is half. This is the question here. Remember, this is the question. Find sine inverse of half. So you check, is half between minus 1 and 1? Yes. So let's find the angle between minus pi over 2 to pi over 2. That's the condition or the restricted domain. So the only angle there is pi over 6, which is 30 degrees. So we can say sine inverse of half is equal pi over 6. Now the second one, find sine inverse of 2, which means find the angle whose sine is 2. There is no angle like that. Just simply, you can see that 2 is not in this domain. You see the domain closed minus 1-to-1, the domain of the inverse. 2 is outside, it is not there. So sine inverse of 2 is undefined. There is no angle like that. Let's find now, example 2, sine inverse of minus 1 plus sine inverse of minus half. Find this one separate, this one separate, and then we add. You can take a minute, please, to try here. Let's see. Sine inverse of -1. Is -1 in the domain? Yes. What is the angle? Must be in this range. So it is only minus pi over 2. So sine inverse of -1 minus pi over 2. Remember here, we cannot write 3 pi over 2 because 3 pi over 2 is not in this range. Now, the second one is minus half. Is minus half between -1 and 1? Yes. Find an angle. It will be minus pi over 6, which is in quadrant 4. So I take the first angle, minus pi over 2. You see this one here? Minus pi over 2. I add minus pi over 6. See, the LCD here is 6. Multiply by 3. Multiply by 3 up and down here. So it becomes minus 4 over 6. So the answer will be minus 2 pi over 3. Now, this is a really nice question. Let's find the value of sine inverse sine pi over 4 plus arc sine 7 pi over 6 divided by sine inverse 7 over 8. Let's see. We have to take each one separate as usual, and then we add and divide. Let's see the first one. Sine inverse sine pi over 4 is equal pi over 4 because of the cancellation property. But remember, you have to check the condition. Sine inverse sine x is equal to x. Is this x pi over 4 between minus pi over 2 to pi over 2? Yes. So we can use it. Also, we can use cancellation property for the value in the denominator here. See? Sine inverse 7 over 8. If we have inverse in the middle here, in the bracket, this should be a number in the domain. So 7 over 8, yes, between -1 to 1. So this one is 7 over 8. So this one, the first term here in the numerator, this is pi over 4, and this is 7 over 8. But this one does not equal to 7 pi over 6. That's the trick. You see? So let's simplify the third one. Arc sine 7 pi over 6 cannot use cancellation property. We cannot use it because 7 pi over 6 does not belong to this. This is outside this range. So we go to quadrant 3 and we see 7 pi over 6. Let's find the reference angle. See, in quadrant 3, the reference will be the angle minus the pi, which is pi over 6. So sine 7 pi over 6, see what I'm trying to do? Simplify the number inside the bracket here. So 7 pi, sine 7 pi over 6 is minus because of the quadrant 3, sine the reference. And we know sine pi over 6 is half, so that's minus half. So to find arc sine 7 pi over 6 will be sine inverse or arc sine minus half, which is minus pi over 6. You see, this is the answer for this. That's a little tricky part here. Now, let's see, from the previous slide, we have this one, and this one. See, this is minus pi over 6. So I put sine inverse sine pi over 4 is pi over 4. This one minus pi over 6, and this is 7 over 8. And then I have to find the LCD here is 12. You see, 12. So this one multiplied by 3 up and down. This one multiplied by 2. So this becomes pi over 12 times the reciprocal will be 8 over 7. So here divide by 4, 2 pi divided by 21 is the answer. Let's see example 4. Find the domain and the range of the function y equals minus pi plus 2 sine inverse 3 minus x. We know the domain and the range of sine inverse, the basic original function without any shifting. Let me show you now what we do. So as I mentioned before, we know the domain of the basic sine inverse is -1 to 1. See, this is the domain. Because here the argument is only x. So the argument belongs to -1 to 1. Let's take the new argument of our function, which is 3 minus x. See, in the domain, I don't use this coefficient. I don't use the minus pi. That's for the range. Now for the domain, I take the argument between closed minus 1 to 1. Always I do that. And now we subtract here 3 from each side. So minus 4 less than or equal minus x less than or equal to minus 2. Now divide all sides by minus 1, change the signs. So x will be greater than 2 and x is less than 4. You see that one? So we can rewrite it x between 2 and 4. So it will be close to close 4. This will be the domain of this function. Let's see the range on the next slide. See, the range of the basic sine is minus pi over 2 to pi over 2. So I take the function. I don't use the argument now. See, sine inverse, that's why I wrote the argument. Sine inverse of any argument will be between minus pi over 2 to pi over 2. This 2 will affect on the range. This minus pi shifting down, it will affect on the range. So let's multiply by 2 because there is a 2 there. So we multiply by 2. So we get minus pi less than or equal to sine inverse argument. And then let's add here minus pi, minus pi, minus pi. See all this now, minus pi plus 2 sine inverse argument. This is the y value. This is what we need here, the y. Between minus 2 pi to 0. So closed minus 2 pi to 0 will be the range of this function. Now the inverse cosine function. What we said about the inverse sine function applies here also in terms of the cosine is not 1-to-1. The cosine, the graph here, you see, it's not 1-to-1. So let's restrict the domain from 0 to pi. That's a fixed condition here. From 0 to pi, see this one here, from 0 to pi, which is quadrant 1 and 2. So the inverse now, y equals cosine inverse, interchange x and y, so x will be cosine y. Let's solve for y. So y, we can write it as cosine inverse of x. So we see the domain of the inverse now is minus 1-to-1. It's coming from the range of the f, you see? So all these values of x, minus 1-to-1, as the sine inverse. Now this one changed. The range of the inverse from 0 to pi. And remember the range for the sine inverse, it's a different condition. So y equals cosine inverse of x, we can write it as arc cosine of x. That's the same meaning. Arc cosine means the angle or arc whose cosine is the x value. So we have seen the cosine restricted domain from 0 to pi. So this is the part of the graph. If we draw the inverse, just take any point on the graph of the f and interchange it. So let's say 0, 1 becomes 0, 1, 0. Pi minus 1 becomes minus 1 and pi. So this is the graph of the cosine inverse, and this is the graph of the cosine function with restricted domain. Remember, this is the domain of the inverse, and that's the range of the inverse. As I mentioned before, it is defined in quadrant 1 and 2, and these are the cancellation properties. The first one is the same condition as the cosine inverse and sine inverse. So cosine inverse of x is equal to x if x between minus 1 to 1. Now, if you have cosine inverse cosine of x is equal to x only if x between 0 and pi. Let's see cosine inverse of half. So you have to find the angle. You have to tell me the angle. It should be in your memory from the table. The angle whose cosine is the half. Since half is positive, so it is in quadrant 1. So this is the meaning here. The question, find cosine inverse of half. It means find the angle in quadrant 1 or 2. Why 1 or 2? Because the condition or the range of the cosine inverse from 0 to pi. You have to check that half is between minus 1 to 1, yes. So what is the angle? 60, or you can write pi over 3. So cosine inverse of half, pi over 3. Let's see a nice question now. we need cosine inverse of minus half plus cosine inverse of square root of 3 over 2. And then we need to add them. So let's find each one separate. Cosine inverse of minus half. See, the x here is minus, right? See, this is minus half. We know minus half is in between minus 1 to 1. So it is in the domain of the inverse, yes. So we can find the answer. We need angle between 0 and pi. Since this is x is negative, that means the angle is in quadrant 2. See, the reference is pi over 3 because of the half. So the angle pi minus pi over 3, which is 2 pi over 3 here. Now, cosine inverse of square root of 3 over 2. What is the angle whose cosine is this? That's positive, so it is in quadrant 1. That will be pi over 6. So we can add 2 pi over 3 plus pi over 6, multiply here by 2 to make the LCD 6. So 5 pi over 6 is the answer. Now for the inverse tangent function, we see from the graph of the tangent, which is in lecture 17, the graph of the tangent, it is not one-to-one. So we have to restrict the domain. So we take one period from minus pi over 2 to pi over 2 open on both sides. Y equals tan of x, so x will be tan of y. Let's solve for y. Y will be tan inverse of x. We can write tan inverse of x or arctan of x, which means the angle whose tan is x. Domain of the inverse, that is the range of the f. What is the range? All real numbers. So x here now, any number we can accept. Positive, negative, fractions, any number I can accept in the x. That's the domain of the inverse of tangent, which is the range of the f. The range of the inverse in the tangent will be the domain of the f after we restrict it. So it will be minus pi over 2 to pi over 2. So this is the graph of the one period, which is one-to-one restricted domain from minus pi over 2 to pi over 2. And this is the graph of the inverse tangent. Remember these domain and range. So we come with this is the defined in quadrant 1 and 4. Now let's look at the cancellation property. Tan inverse of x is equal to x. For x belongs to R. So any number there we can accept. Please be careful here to understand this. Any number, we can put half, it will be half. If we put 7, it will be 7. If we put 100, it will be 100. If we put minus 5,000, it will be minus 5,000. Because x belongs to R. Now, tan inverse tan of x is equal to x. Only true if x between open minus pi over 2 to open pi over 2. Now let's see, we have in this example 7, 4 parts, A, B, C, D. Arc tan of 0, tan inverse of minus 1, tan inverse of 5, tan inverse of square root of 3. This is easy question. Tan inverse of 0, find the angle whose tangent is 0. That angle is 0. Because sine of 0 is 0, cosine of 0 is 1. 0 over 1 is 0. See, 0 in between minus infinity to infinity, and the angle is between minus pi over 2 to pi over 2. So arc tan of 0 or tan inverse of 0 is 0. Tan inverse of minus 1. Remember, the answer should be from minus pi over 2 to pi over 2. So it will be minus pi over 4 because we know tan 45 is 1. And since we have this is a minus, so it goes to quadrant 4. Now, tan inverse of 5, there is an angle tan inverse of 5. Remember, because 5 in the domain from minus infinity to infinity, you can put 5, you can put 15, 17, minus 29, minus 1,000, 0.1. You can put any number there, but you have to use a calculator, unfortunately. Tan inverse of 5, it's not a special angle. So go to the calculator, put 5 tan inverse, it will give you 78.69 degrees. So there is an angle, whatever the number here. Now tan inverse square root of 3, that's a special angle. It will be pi over 3. Now, example number 8, find the value of sine cosine inverse 2 over 5. This is a very important question because this angle is not special here, but that's an angle inside the bracket, cosine inverse 2 over 5, that's an angle. So what is the meaning of this question? We need to find sine of this angle. The angle is not known, but we know the cosine of that angle is 2 over 5. So that's the question now. Find the sine of the angle whose cosine is 2 over 5. So since this is an angle, I say let theta equals cosine inverse 2 over 5. Let's take cosine on both sides here. Cosine of this theta is equal cosine of all this value. Now, cosine theta, we leave it. Just take the bracket out. Cosine inverse of x is equal to x in the cancellation property because this x between minus 1 to 1. So now I have cosine theta 2 over 5, which is x over the r, or the adjacent over the hypotenuse. So if we have a theta here, so this is 2 and this is 5. So let's find the y value. Use x squared plus y squared is equal r squared. So this is 2 squared plus y squared is equal 5 squared. Let's find y on the next slide. So from the last slide, we see y squared is equal to 25 minus 4. So y squared will be 21. Y will be plus or minus square root of 21. Choose the plus since the cosine inverse is defined on the interval 0 to pi, which is quadrant 1 and 2. So y should be positive. So we take y plus square root of 21. Now, what do we need to find? Sine of cosine inverse 2 over 5, which is sine of the theta, which is the opposite over the hypotenuse, or y over r. Square root of 21 over 5 is the answer. Now, let's make a summary here, please, for the cancellation properties. Inverse sine function, as I mentioned before, sine of sine inverse of x is equal to x only if x between minus 1 and 1, and sine inverse sine of x is equal to x only if x between minus pi over 2 to pi over 2. Same thing for the conditions on the cosine inverse and the conditions for tan inverse. Please review these. And all of these, they are coming from this f of f inverse of x is equal to x, and f inverse of f of x is equal to x. Now, this is another summary. Given here the domain and the range and the quadrant of the inverse sine function. That's the same color here. You can see this is quadrant 1 and 2. The domain will be minus 1 to 1, and the range will be minus pi over 2 to pi over 2. This is another way to remember it in a nice way. Y equal cosine inverse of x. The domain will be minus 1 to 1, and the range 0 to pi. It is in quadrant 1 and 2. And tan inverse, the domain will be all real numbers, and the range minus pi over 2 open to pi over 2 open. Let's look at example number 9. Good question. Find the value of r cosine 2 pi over 3 plus cosine inverse of cosine 5 pi over 4, all divided by cosine inverse of minus 1. Now we start by cancellation property because r cosine means cosine inverse. Cosine of x is equal to x if x between 0 and pi, which is quadrant 1 and 2. And yes, 2 pi over 3 is in quadrant 2. So this equals 2 pi over 3. Now let's get the value of the angle here, whose cosine is minus 1. The angle is pi. Now let's see the second term in the numerator here. Cosine inverse cosine 5 pi over 4. We cannot use the cancellation property because 5 pi over 4 does not belong to 0 to pi. So we have to go to quadrant 3 here, 5 pi over 4, find the reference angle, which is 5 pi over 4 minus pi, which is pi over 4. Then Cosine 5 pi over 4 will be minus because it's in quadrant 3. Cosine the reference angle, pi over 4. So the answer minus square root of 2 over 2 is inside the bracket here. Now we ask, what is cosine inverse minus square root of 2 over 2? What is the angle between 0 to pi, whose cosine is this negative number? So it is 3 pi over 4. Let's put everything together here. So the first one is 2 pi over 3. See the second term here, 3 pi over 4. And in the denominator, we have pi. So this is the LCD 12. So it becomes 8 pi over 12 plus 9 pi over 12. Multiply here by 3, multiply here by 4. So when you add, you get 17 pi over 12. And this pi multiply by the reciprocal, 1 over pi. So you cancel the pi, and the answer is 17 over 12. Example number 10, it looks like an exam type. Find tan of sine inverse minus 5 divided by square root of 41 plus tan inverse minus 5 over 8. Now, if we look at the first term here, tan sine inverse of minus 5 over square root of 41, we see this sine, S-I-G-N, is minus. That means the angle lies in quadrant 4. So let theta be this value inside the bracket here. So theta equals sine inverse minus 5 over square root of 41. Take sine of both sides. We get sine of theta is equal minus 5 over square root of 41. We have done many times the same way here. So this will be y over r, so we can find x. So y will be the minus 5 and r will be square root of 41. So use x squared plus y squared is equal r squared. So I can leave x squared plus 25 here is equal 41 when you square this. So x squared will be 16, x will be plus or minus 4. So in quadrant 4, we take x positive. Quadrant 4, and this is the condition of the sine inverse. Now, from the last slide, we had x is equal to 4. So let's take the first term here, this term here. So tan inverse of this will be tan theta. See, this is all theta from the previous slide. So tan theta will be y over x, which is minus 5 over 4. This is the first term. Let's see, the second term is easy because we can use tan cancellation property. So tan inverse of any x will be the same x. So it will be minus 5 over 8. So we can add minus 5 over 4 plus minus 5 over 8. The LCD is 8. Multiply by 2 up and down. You get minus 15 over 8. Now, I will leave some questions for you here to practice as all the exam questions. Find the exact value of this quantity here. All this expression, you need to find the value. So you can start sine inverse of minus square root of 2 over 2. You find the answer there, then you square it. Plus cosine inverse of minus square root of 2 over 2. Find the value, then you square it. All divided by cosine inverse cosine of 3. Remember here, 3 is an angle in radians. Question number 2, evaluate the expression cosine inverse cosine 6 pi over 7 minus sine inverse sine 6 pi over 7. Try to do that. Question number 3, find the domain and the range of this function y equals minus cosine inverse of 2 minus x minus pi over 2. You can find a similar question in this lecture number 19 about inverse. Question number 4, find the value of tan of sine inverse half plus cosine arc tan square root of 22 over 3. Try it, please. And number 5, find the value of the expression tan inverse tan pi over 4 plus tan inverse tan 5 pi over 6, all divided by square root of 2 sine of tan inverse of minus 1. Try that. And question number 6, find the value of tan inverse of minus square root of 7 divided by this sum here, tan arctan of 25 plus tan inverse of minus square root of 25. Now, as usual, these are the answers, the final answers of these 6 questions. You can try them, please. For complete solution, you can see the video on the inverse trigonometric functions, lecture number 19, pre-calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I would like to remind you that this is pre-calculus course, lecture number 19. I wish I can see you in another video with another topic. Thank you for listening.